when we want to understand the relationship between variables. So for example, I want to know if academic motivation and performance is related to each other, or I want to know if parental stress and their overall mental well-being are related to each other. So you're doing very, very relationship-based studies where you're wanting to understand if two things that you're looking at, are they related to each other or not. Now, regression and correlation are again, they're like two sides of the same coin. So regression is, again, you're not just looking at how let's say academic motivation is related to your performance, but you're also looking at how much do you have to be motivated for your performance to go up, or if academic motivation starts going down, how is that going to impact your performance. So of course we can only make these predictions once we have established that there is a relationship between the two variables that we are looking at. Again, something which is not often understood, and it's a very common mistake that we tend to make, but correlation and regression are pretty much the sides of the same coin. If you've established two things are not related to each other, there is no reason to run a prediction, because what are you predicting when two things are not related to each other? We don't need to go further into predicting how one is going to, have an impact on the other. So these are very, very closely related to each other, and that is why when you see studies will say relationship as part of their title, but when you look at their data analysis, they would have definitely done a regression as well, because it goes without saying that if you are establishing relationships, then you want to go a little further. You want to also understand how much of increase or decrease in one is going to lead to an increase or decrease in the other variable that you're looking at. Then comes t-tests and ANOVAs, where we are looking at comparing different groups. So now we're not looking at variables in terms of an independent variable or dependent variable and so on. We're looking at comparing groups. Now this is a very, very common trend right now, where people generally want to do gender-based studies, where they're wanting to see how men and women could be different on a particular parameter, or how let's say you want to compare people from the LGBTQ community. So you have different groups of people that you're taking and seeing how they could be different on experiences of a particular thing. Or let's say, people do it in terms of marital statuses, people do it in terms of educational qualifications, people do it in terms of your place of living, people do it in terms of the number of children that somebody has, or are you in a committed relationship or you're not in a committed relationship. There is a whole variety of combinations that can be picked up. Only thing that needs to be understood here is the minute we are touching t-test and anything above, we are looking at comparing groups with each other on a particular variable. So like I said, you're comparing gender on, let's say, their overall mental health, or let's say you're comparing people with different educational qualifications in the kind of jobs that the market can offer to them, or the kind of packages that they get in the market when they're applying for a job. So you're looking at comparing different groups of people with each other to see are there group differences in terms of the variable or the dependent variable that they are experiencing, or they are or what you are looking at. So if this is understood, the first struggle of understanding what test is my study going to or what test is going to serve the purpose of my research, this kind of makes it very, very comprehensive, or makes it very easy for somebody to take a decision. And trust me, books don't give us this. This is something that I have personally made for my own understanding, because it makes it very easy for you to then understand that, okay, if I'm looking at comparing two groups, I know I'm looking at t-test. If I'm looking at comparing 3 different groups or 5 different groups with each other, I'm looking at ANOVA as the statistics or the analysis that I need to run. So if you look at descriptive versus inferential, you're looking at how descriptive stops at just giving you a very good summary or a very good infographic, but inferential goes much deeper. Inferential takes out as much as it can from the data that you've collected to give you as many possibilities that you can. I'm sorry, if you can please keep yourselves on mute. So inferential allows you to kind of, go much forward and do whatever possibilities or however you can explore and exploit the data that you've collected from a group of people. So this is just what I told you right now. So again, if you're looking at mean differences for two groups, you're looking at something like a t-test. They will have their further divisions. You'll have independent sample t-test paired. I'm not going into so much detail because then, like I said, it's not something that can get wrapped up in 45 minutes. It's of course an entire session on its own. But these are basically multiple divisions in terms of how, based on now the kind of data that you have, the number of groups that you have, the number of variables that you have, you can then take a call on, am I stopping at T, or am I going forward to an ANOVA, or am I just, because I'm just wanting to look at relationships between variables, can I just look at correlation and not go further? All those decisions get taken over here. So choosing a statistical test, like I told you, will depend upon A, the kind of variables that I have, B, do I have groups amongst my variables, or is it just solid variable A with variable B? Do I have anything in terms of, I am not just taking the variable as a whole, but my variable has levels. So for example, you're looking at mental retardation and you have 4 levels there. So you can't get a whole score on mental retardation. You'll get people under levels. You will have somebody coming under mild, somebody coming under moderate, and then these are again subgroups that you're wanting to compare with each other. So those will all decide, or those will all be deciding factors for us to choose a statistical test. And I absolutely understand that, at the master's level or the dissertation level, this is our biggest challenge. This is our real challenge in terms of, how do I choose a study, and do I need to decide a test before I choose a research study, or should I have the study first and then decide or understand what kind of analysis is going to do justice to that? So this is of course an ongoing challenge that we all have. But once we understand the basic purview of these tests, of how one is related to difference, how one is related to relationship, how one is related to prediction of a relationship, from there it gets easier for us to kind of take a call. And I'm not saying it happens overnight, but it at least becomes a starting step for us to understand how different data or different information that is coming to us can be subjected to so many different types of analysis in the same study. You may not have to run 5 different studies for using 5 different tests. Sometimes the same data that we are collecting can allow us to run a correlation, can allow us to run a regression, can also allow us to run a t-test. It completely depends upon what are the different areas, or what are the different segments under which we are getting data from our group of people. So that's basically your conclusion in terms of descriptive. Of course, like I said, it's more of a summary, more of giving people a glimpse of what is the kind of data that I collected. And when you try to draw conclusions from there, when you try to go deeper into how this can be used for understanding bigger things, or can be used more to replicate to a larger group of people, that's where we come down to inferential statistics as our go-to statistics, to not just stop with a bar graph or a pie chart, but to go much further into how this can be explored more, or this can be understood more. So I hope I've been able to give you some small glimpse on what basically what the basic difference between descriptive and inferential is. And now we can open the platform for questions. I think we can take about 5 minutes of questions. So anyone who has a question, something like factor analysis, all of that done, and then you're coming down with a possible scale or a tool that can be used to measure something. So when you say applied is basically nothing but basic statistics and applied. Basic is very theoretical part that we are doing. That mean ये होता है, median ये होता है, standard deviation ये होता है. This is how it's calculated. When you come down to using that to calculate further things, that's when it starts becoming applied from there.
Thank you, ma'am.
All right. Okay. Somebody else had a question too? Okay, so I think Saurabh has put a question. Saurabh, your second question is going to take a very long time, so I am unfortunately I can't pick that up right now. But when you say what is the difference between universe, population, and sample, so in very, very simple terms, universe is where you're looking at every universe is like the larger set of people that you're looking at. Population is basically, so for example, if I say teenagers, your universe is teenagers, which is all possible teenagers living across the globe. Now when I come down to population, suppose I specify that I'm going to look at teenagers only between standard 6 to 8. Now, my population becomes only those teenagers who are studying in standard 6 to 8. Now, my sample will be, suppose I say I'm going to look at teenagers who are studying between standard 6 to standard 8, and they're studying in, suppose, NCR, or they're studying in Delhi, Haryana, Faridabad, or around the regions around that. That becomes my sample. So the more we are specifying and the more we are cutting down on the larger group that we have, that's how these words come. So universe will be teenagers across, all teenagers, all ages, whatever they are doing, all genders. When you come down to population, you're looking at teenagers, let's say, like I said, only studying in a particular class. So you're not looking at 13 to 18, but you're looking at teenagers only in the classes 6 to 7. Or 6 and 7, and sample will be, I'm kind of trimming it down even more. I'm saying I'm looking at teenagers studying in standard 6 and 7, but I'm only looking at, let's say, boys, or I'm only looking at girls, or I'm only looking at a particular state or a particular region or a particular country. That's where I've gone from teenagers all across the world to teenagers studying in standard 6 and 7 to teenagers studying in 6 and 7, and with another terms and conditions apply. So sample becomes your go-to. Sample is all those people from whom you will be collecting your data. So naturally, the number becomes much smaller as compared to the population, as compared to the universe. I hope he was in the chat and he's heard the answer. Yes, all right, Saurabh, thank you. So if we don't have any more questions, thank you so much for being patient, and I hope I've been able to